This is Unit 10, Organic Chemistry, Lesson 6, Organic Reactions. How are organic compounds produced? The objectives of this lesson: I can identify the types of reactions, and I can determine the product of substitution and addition reactions. Do now. There are 8 types of organic reactions, and these are how organic molecules are formed. Type 1, combustion reactions. This is when an organic compound is burned in the presence of oxygen to produce CO2 and H2O. O2 is always a reactant. So here we have CH4, which we've learned the name is methane. And when we add oxygen and burn it in the presence of oxygen, we produce CO2 and water. Recall from Table I, the first 6 reactions on Table I are examples of combustion reactions, and we talked about that. Just as a side note here, notice how much energy is produced in this reaction. This is actually the reaction that occurs in your car to allow it to drive. The second type of organic reaction is called substitution. It's similar to single replacements, where 2 atoms are switched. The first compound is always saturated, which means it has single bonds. So you can remember all these S's. It's substitution, similar to single replacement. The first compound is saturated, which means it has only single bonds. And what usually happens is one hydrogen is switched with one halogen, which is from group 17. So for example, here's our methane. We're going to add the halogen chloride or chlorine. This is the element chlorine. And what happens is one H from this methane will switch places with one Cl here. So notice here's the Cl, here's the H. They've switched places. That means it's been substituted. A second example is, here is ethane, where we'll add our chlorine. And here we'll take one chlorine and switch places with one hydrogen. And therefore we have a substitution. And notice that our organic compound has only single bonds. Our third type is addition. In this case, we'll have double or triple bonds being broken and where 2 or more atoms are added. Therefore, our beginning molecule must be unsaturated. So that's very important. Unsaturated means it has double or triple bonds. So double or triple bonds. And what I'll do is I'll take my halogen or hydrogen, and what I'll do is I'll add them together. So notice I'll take these double bonds and rip it apart, and now the bromines, both of them, have been added to this molecule. That's an arrow. Our second example is, this is propene. We're going to add chloride to it. If I just add it, what I'll do is I'll place them in these empty spots where there should be hydrogens and break my double bond. So I'll have 3 carbons all in a row, and now I'll have my H's that were there before. And I'm adding a chlorine and a chlorine. Otherwise, everything else remains the same. So these 2 chlorines now are added right here. Our fourth type of organic reaction is esterification. This forms esters, which have smells. So you can identify an ester as a product. So in order to do that, you'll have to use Table R like we did in our last lesson. And what we'll always do is we'll always have an organic acid with an alcohol, and we'll form that ester. Recall the ester has that O breaking the bridge with that double bonded O. So this is your ester group from Table O. So you'll know it through this reaction. And then our first products are going to be an alcohol and an organic acid. So this is an important one. Our fifth type is fermentation, which we learned about in living environment. This is the enzymatic breakdown of sugar into alcohol and CO2. So we'll always identify this by having an alcohol as a product and CO2 as a product. 6 is saponification, and I always remember this one because saponification starts with S, and so does soap. So this is how we make soap. And what we do is we hydrolyze fat using a base, and we'll produce our soap and glycerol. So that S there for soap, like sapo, this is almost like soap. That's how I remember it. We'll identify soap as a product, and a base as a reactant. So our base is going to typically be NaOH. Our seventh type is polymerization. This is the formation of long chain molecules or polymers from small repeating subunits, or our monomers. So we've also talked about this from living environment, the polymerization of peptides, for example. There can be natural polymers such as proteins or peptides, or artificial. Plastics are examples of artificial polymers. So some examples of natural, these are 3 examples of natural polymers: starch, proteins, and cellulose. So keep those in mind, which we recall from our living environment. There are 2 types of polymerization: addition polymerization, and this is by adding small alkenes together by breaking the double bond to create a large chain. And we'll identify those because we'll have these parentheses with this little n, and this n means it's a very large number. We have a lot of little pieces stuck together. And you'll identify them by the repeating units, or the monomers, by creating one giant molecule. So what we can do here, this is our making a plastic. We'll take ethylene, which is small pieces, and we'll combine them together to form polyethylene. And this is a form of plastic. Our second type of polymerization is condensation reactions. And this is where we join 2 molecules together by removing water. And we did a lot of this in living environment. So here's our water, and we'll join them together. This is how peptides are produced. So this is an example of peptides, and we made a peptide bond. The 8th type is called cracking, and this is how we produce a lot of those gasolines that we use in our cars. And what it is it's breaking large hydrocarbons into smaller chains by heating them. And this is what we do to fossil fuels. So when we take them out of the ground, we crack them into many components, such as octane, which is a form of gasoline, propane, which we also use, and other types of things. So we take a large hydrocarbon and break it into many pieces. One thing you'll be asked to do, is find the missing reactants and products in organic reactions. So in a balanced reaction, the number of atoms on the left will equal the number of atoms on the right. I know the yellow is hard to see. It's my apologies. This says equal, and this says right. So this is really important. This is our law of conservation of mass. So if we have all of these together, C2H6 plus Cl2 will produce C2H5Cl. What is our missing product? The way you'll do that is list everything on the left side, everything on the right side, and see what's missing. So in this case, we have 2 carbons and 2 carbons accounted for. We have 6 hydrogens and 5 hydrogens accounted for, which means we're missing 1. We have 2 chlorines and 1 chlorine, so that means we're missing 1. So the missing product must be HCl, because that's what we're missing in our that's what we're missing. This is a substitution reaction because the hydrogen of the ethane is replaced by chlorine. So practice, identify the type of reaction. So looking at this, what I can see is I have a saturated hydrocarbon here, and I have chlorine. And what I've done here is I've taken a hydrogen and switched places with the chlorine. So therefore, this is substitution. Identify the type of reaction. So if I look at this, what I see here is unsaturated. I have a double bond here, and I'm adding hydrogen, and now I've formed an alkane. So this, I've done addition. Check your understanding. And 4 and 5. And now you can identify the types of reactions of organic compounds, and you can determine the products of substitution and addition reactions.